Today we're going to look at our third type of solving logarithmic and exponential equations. And this is if you are given a situation where you have a log on one side and a log on the other side. So the first two types we saw where we had something raised to a power on one side and something raised to a power on the other side of the equal sign. This one today will have a log on both sides of the equation. So if this is the case, like our first example here, what we're going to do first is condense both sides of the equal sign if we need to. So in this example here, we have one single logarithm on the left and one single logarithm on the right. So we don't need to condense either side. Since we have both of these logarithms equal to each other, we can go ahead and just set these expressions here equal to each other because everything else is the same. So we have 3x minus 7 equals 5x minus 15. And then step 3, solve for x. So add 7, subtract 5x, and divide by negative 2. So x equals positive 4. Now one thing we need to be concerned about is when we plug in that positive 4 back into this expression here or this expression here, we want to make sure that if we were to evaluate 3 times 4 minus 7 or 5 times 4 minus 15, that we would go ahead and get positive numbers in both cases, which we do. So that one's good. This one here, next example, I have the log base 4 of x plus 4 minus log base 4 of 2 equaling the log of base 4 of 7. On the left side, I see more than one logarithm, so I'm going to need to condense those. Remember, if you have two separate logarithms that are being subtracted, you can condense that to be log base 4 of x plus 4 divided by 2 equals log base 4 of 7. So subtraction can put them together into division. Now I have a single logarithm on both sides. I can go ahead and take the expressions x plus 4 over 2 and 7 equal to each other. X plus 4 over 2 is a fraction. Let's make 7 look like a fraction, and now we have a proportion. So 2 times 7 is 14. That equals 1 times x plus 4. So 14 equals x plus 4. 10 equals x. Double check, is it okay to have 10 in the expression here? 10 plus 4, that gives me a positive result, so yes, that's okay. The next one here, I have log base 7 of x plus log base 7 of 9 equals log base 7 of 54. We need to go ahead and condense the two logarithms on the left-hand side. Because they're both being added, we can combine them together into be one single logarithm and multiply x times 9, which is 9x. I now have one single logarithm on both sides, so I can go ahead and take those expressions 9x and 54, set them equal to each other, and go ahead and solve for x. So x equals 6. Double check. Is it okay to put 6 in here? Will I still have a positive expression? And yes, it'll be log base 7 of positive 6. Three, natural log 5 minus the natural log of x equals natural log of 5. So I need to condense the left-hand side. Remember, this 3 is an exponent, so really this is natural log of 5 to the third minus natural log of x equals the natural log of 5. I have two logarithms that I'm going to go ahead and that are being subtracted, so I can condense them into one using division. 5 to the third is 125, so it's really 125 divided by x equals the natural log of 5. I have two single logarithms on each side, so I'm going to take the expression 125 over x and set it equal to 5. As I did before, since I have a fraction on the left, I'm going to make the one on the right look like a fraction. Cross multiply. 5x equals 125. So dividing by 5, x equals 25. Log base 11 of x plus log base 11 of x plus 1 equals log base 11 of 6. Condense the left. By multiplying. Okay, so I have a single logarithm on the left, a single logarithm on the right. I can go ahead and set those expressions equal to each other. So x squared plus x, I just went ahead and distributed this, equals 6. This is a quadratic equation. I'm supposed to solve for x. So the first thing I'm going to do is set it equal to 0. And hopefully I can factor this. Let's see what multiplies. To get negative 6, and what adds to get 1? That would be 3 and negative 2. And since we see that there's a 1 in front of the x squared, remember we don't have to use the boxes. X plus 3, x minus 2. Multiplying those together to get 0. So x must be negative 3 and positive 2. Now if I take positive 2 and I look up here, put it in here and here into the original problem, that's just fine. That expression is still a positive number. However, if I were to take negative 3 and plug it in right here, I'd have log base 11 of negative 3, and I can't have that. I can't be taking the log of a negative number. So this one is out, and my only answer in this case is x equals 2. Today, you have a worksheet 7B. Please make sure that you're checking your answers. Let me know if you have any questions, and we'll go from there.